Alice, Bob, and Eve explain quantum circuits and initialization.
I'm setting up these dominoes for a chain reaction, but I need to plan the starting positions carefully based on the pattern I want at the end.
You know, what you're doing is remarkably similar to designing quantum circuits.
Quantum circuits. That's exactly what this looks like, especially the initialization part.
How does setting up dominoes relate to quantum computing?
In quantum computing, we create circuits made of qubits and quantum gates, like your domino pattern. But just like your dominoes, how we initialize the qubits at the beginning is crucial to what we want to accomplish.
Each of your dominoes has a starting position, standing upright. In quantum computing, we typically initialize qubits in the zero state, which is like having all dominoes perfectly upright.
But sometimes I need to place a few dominoes differently to get the pattern I want.
Exactly. Different quantum algorithms require different initializations. For some algorithms, we might want to start with qubits in superposition.
Let me use this coin here for another analogy. It's like placing some dominoes standing upright and others at an angle. For example, applying a Hadamard gate to a +0,0 qubit creates an equal superposition of 0 and 1, like balancing this coin on its edge instead of flat on heads or tails.
What about more complex setups?
For algorithms like quantum search, we initialize by putting all qubits in superposition, creating a massive parallel state that represents all possible solutions simultaneously.
And for simulating quantum physics, we might initialize qubits to represent a specific quantum state of the system we're studying.
So the initialization depends entirely on what problem you're trying to solve.
Precisely. For quantum machine learning, we might encode our classical data into quantum states. For optimization problems, we might initialize to represent all possible solutions.
Your domino circuit has a specific layout designed for your final pattern. Similarly, quantum circuit design, including initialization, is tailored to the algorithm's purpose.
And just like you carefully test sections of your domino pattern, quantum algorithms often include verification steps to ensure proper initialization.
And like me placing this final domino here, what about measuring the results?
That's when we read out the final state after all the quantum operations, like watching which pattern your dominoes form when they fall.
But unlike classical dominoes that deterministically fall in one way, quantum measurements collapse superpositions probabilistically, giving us outcomes based on the interference patterns we've created.
So my domino chain is like a quantum circuit frozen in time, with its initialization determining what happens when I tip the first one.
Exactly, though your dominoes can only fall once, while quantum circuits can be reset and run millions of times to gather statistical results.